Oumuamua's brief yet unforgettable 2017 journey, when the telescopes of Earth first caught sight of Oumuamua in the autumn of 2017, the discovery was as sudden as it was extraordinary. Astronomers, scanning the heavens with the Pan-STARRS survey in Hawaii, noticed an object unlike any they had ever tracked before. At first, it was catalogued as a comet, then quickly reclassified as an asteroid, and finally acknowledged as something altogether different: an interstellar visitor, the first ever confirmed to pass through our solar system. Oumuamua, whose name in Hawaiian means a messenger from afar arriving first, carried with it both the romance of language and the profound realization that humanity was witnessing an emissary from another star. Its trajectory made the story clear. Unlike the comets and asteroids that are bound by the gravitational embrace of the Sun, Oumuamua was moving too quickly to be captured. It had entered our solar system from interstellar space, swept around the Sun, and was already on its way back out toward the endless dark, never to return. The speed of this traveler was breathtaking. At its closest approach to the Sun, Oumuamua was racing at over 50 miles per second, a pace that ensured no planet, not even the Sun itself, could hold it. This speed alone announced its alien origin, but it was the object's shape and behavior that deepened the mystery. Unlike the icy comets that typically trail luminous tails of gas and dust when warmed by sunlight, Oumuamua showed no such display. It remained eerily silent, a dark shard against the bright backdrop of space. Measurements of its brightness revealed even stranger qualities. The light curve suggested that Oumuamua was not spherical like most asteroids, but rather elongated, spinning as it tumbled through space. At first, it was thought to be shaped like a cigar, perhaps 10 times longer than it was wide. Later studies proposed a flattened, pancake-like form. In either case, this was no ordinary rock. It reflected sunlight in a way that shifted dramatically with its rotation, hinting at surfaces both smooth and fractured, a body shaped by forces we could only imagine. For astronomers and planetary scientists, this was a revelation centuries in the making. For generations, thinkers from Isaac Newton to 20th century astrophysicists had speculated that fragments of rock and ice might wander between the stars. Oumuamua was the first proof of such a reality, a tangible confirmation that the gulfs between solar systems are not empty but seeded with debris ejected during the violent births and deaths of planetary systems. And yet, the object defied many expectations. If it had been launched long ago from the gravitational upheavals of a distant star, why did it not carry the icy mantle of a comet? If it was an asteroid, how had it been cast? The sudden detection of 3I Atlas, only a few years later, the skies revealed another messenger. In 2023, the Atlas survey in Hawaii detected a faint but swift object streaking on a hyperbolic orbit. This was 3I Atlas, the third confirmed interstellar object to visit our solar system. Unlike the puzzling silence of Oumuamua, this newcomer shone with activity. It developed a glowing coma and a streaming tail, unmistakably the signature of a comet. This was a revelation of a different kind. Here was material forged under another star's light, reacting to our own sun, as if to prove its kinship with familiar comets. And unlike Oumuamua, which we glimpsed only as it fled, 3I Atlas was spotted inbound, giving astronomers precious time to observe and prepare. Its arrival underscored the importance of sky surveys, not only for planetary defense, but for catching these cosmic drifters before they slip away. Speed comparison between the two interstellar visitors. Speed is one of the clearest signatures of an interstellar traveler. Oumuamua raced through at nearly 55 miles per second, fast enough to escape the sun's grasp with ease. 3I Atlas, however, was moving even faster. Its hyperbolic excess velocity, The speed it carried even beyond the Sun's pull was greater than that of its predecessor, suggesting an origin far deeper in the galactic wilderness. These speeds are not arbitrary. They carry the memory of distant gravitational encounters. Somewhere in another star system, long ago, these objects were flung out by planetary giants or catastrophic collisions. Their present velocity is the echo of ancient dynamics, preserved over millions of years of wandering between the stars. Differences in size and structure. Beyond speed, the differences in their shapes and scales fascinated astronomers. Oumuamua was small, perhaps only a few hundred yards in length, and oddly elongated or flattened, unlike most bodies in our solar system. Its structure raised questions. Was it a fractured shard of a larger world, or an exotic remnant, sculpted by forces we cannot yet explain? 3I Atlas, by contrast, appeared larger and less compact. Its nucleus, cloaked by a cloud of gas and dust, hinted at a structure more fragile, perhaps prone to breaking apart under solar heating. Where Oumuamua seemed like a hardened survivor, 3I Atlas was more like a traditional comet, icy, fragile, shedding material as it neared the Sun. These structural contrasts reminded scientists that interstellar objects are not a single category, but a spectrum, each shaped by the environment of its birth system. Light curve patterns and spin rates. Light, flickering and fading as these bodies turned, told astronomers about I Atlas. By comparison, showed a more complex light curve because its bright coma masked the exact rotation of its nucleus. Yet, the variability in its brightness revealed jets of gas and dust spouting in different directions as sunlight heated its surface. These light patterns painted portraits of motion, one a silent tumbling shard, the other a living comet, active and restless. The role of cometary activity in 3I Atlas's behavior. He ensaisi to bedin and he sees this group's close. The activity of 3I Atlas became a defining difference. Where Oumuamua remained stubbornly inactive, 3I Atlas behaved like the comets we know, sublimating ice, expelling streams of dust, and forming a luminous halo. This activity gave scientists clues to its composition, suggesting that it carried familiar ices such as water, carbon dioxide, or even carbon monoxide. This made 3I Atlas a scientific gift. By studying its emissions, astronomers could analyze material forged under another star's light, perhaps in a system very different from our own. Every wisp of gas it released was a chemical fingerprint, a glimpse into the processes that shape planets and comets across the galaxy. Origin possibilities based on orbital path. The orbital paths of both visitors provided hints of their origins, though never certainty. Oumuamua arrived from the direction of the constellation Lyra, while 3I Atlas approached from another stretch of sky. Neither path traced back cleanly to a specific star, for the journeys of such objects can take millions of years, long enough for their parent systems to drift far across the galaxy. Still, simulations suggested possibilities. They may have been ejected from young planetary systems, where giant worlds scattered debris like sling stones, or they may be remnants of catastrophic collisions, pieces of shattered comets or worlds cast adrift. What is certain is that both were born in places far from here, carrying with them the signatures of alien suns. In the trop, whether the Artuses, see we are doubt, or injecting the Tuses really, know these connections never become far
of an otherworldly origin, as a bold few in the scientific community dared to propose.
This question, teetering between the boundaries of science and speculation, invites us on a journey unlike any other. A journey that doesn't just study the stars. It challenges the very foundation of how we define the universe. JWST was not merely a telescope, it was humanity's eye into the ancient past and the distant And now, the eye turned toward a singular, vanishing point in our cosmic periphery. With each second that passed, Oumuamua moved further away, fainter, more elusive, and shrouded in mystery. Yet the infrared capabilities of JWST allowed scientists to probe for subtle thermal signatures, offering clues that visible light could never reveal. Data streamed back, complex, rich, mysterious. Every spectrographic line, every pixel captured by JWST's detectors held the potential to rewrite what we knew, or thought we knew. About what was it made of? Was there outgassing? Did it behave like a comet cloaked in unfamiliar ices? Or was its propulsion due to something more exotic? Perhaps a structure so thin and light it rode on solar radiation like a cosmic sail. Theories blossomed as the data trickled in, ranging from the conservative to the spectacular. Some suggested it was a fragment of a Pluto-like exoplanet, with an icy composition of hydrogen that evaporated invisibly in sunlight, giving it the strange acceleration observed. Others posited more radical ideas. A light sail of artificial design, crafted by an alien intelligence and sent across the stars on a silent reconnaissance. Whatever its nature, Oumuamua had become a celestial catalyst, igniting a renaissance in interstellar science. NASA and space agencies across the world began envisioning missions specifically designed to intercept future interstellar visitors. Missions that could launch on a moment's notice, outfitted with the tools to analyze, capture, or even return samples. The shockwaves that Oumuamua sent rippling through the scientific community continued to resonate. It shattered assumptions about the frequency of interstellar visitors, once considered nearly impossible to detect, now seen as inevitable. And with new surveys like the Vera C. Rubin Observatory and missions such as ESA's Comet Interceptor on the horizon, we stand ready to meet the next cosmic nomad. But Oumuamua's greatest legacy may not lie in its composition or trajectory, but in the questions it forced us to ask. How many other interstellar travelers pass through our solar system unnoticed? What secrets do they carry? Ancient histories of alien worlds, or the whisper of civilizations unknown? And perhaps most poignantly, what else is out there, waiting to be discovered? In the quiet that followed Oumuamua's departure, humanity was left with more than just mystery. We were left with purpose, a renewed sense of exploration, a deepened thirst for knowledge, and a profound understanding that we are not isolated specks in a cold void, but participants in a vast and dynamic universe, where messages may arrive on trajectories not written by human hands. And next time, we will be ready. With its state-of-the-art instruments, the James Webb Space Telescope, JWST, emerged not just as an observational tool, but as a technological sentinel tirelessly watching the celestial horizon. This marvel of engineering granted humanity unprecedented access to the hidden secrets concealed within the universe's most enigmatic wanderers. For the first time in history, we had a window not merely to observe, but to truly understand. More than a telescope, JWST became a bridge between worlds, a cosmic conduit linking Earth's curious minds to the vast and ancient corners of the cosmos. With its unmatched sensitivity to infrared light, it pierced through veils of cosmic dust, unveiling stars in their infancy, galaxies at the edge of time, and interstellar visitors like Oumuamua, whose mystery had long evaded clarity. Every photon it captured carried a message from across time, some billions of years old, now decoded by JWST's precision instruments. It transformed faint flickers of distant objects into vivid portraits, each pixel enriched with the story of a star's birth, a planet's atmosphere, or a foreign object passing silently through our solar system. As the telescope's golden mirrors aligned and its cryogenic instruments hummed in harmony, JWST did more than observe. It wove together a living tapestry of the cosmos. These weren't just images. They were histories, futures, possibilities, an atlas of the unseen, stitched together in infrared brilliance. And as its lenses focused, and its detectors recorded the light of ancient and alien realms, it felt as though the telescope itself were a cosmic traveler, embarking on an odyssey not through space but through knowledge. Each revelation brought us closer to understanding the grand design of the universe, revealing that behind every shadow lies a story waiting to be told. In the silent vacuum of space, JWST speaks for us, asks for us, seeking answers to the greatest questions ever posed. Thus, the James Webb Space Telescope is not just a machine, it is our ambassador to the infinite, a shining testament to human curiosity, collaboration, and our unyielding desire to explore the unknown. As interstellar objects danced within the focused gaze of the James Webb Space Telescope, JWST, their faintest whispers of light, once elusive and invisible to the naked eye, were brought to life with breathtaking clarity. Structures that were once shrouded in cosmic obscurity now emerged like brushstrokes on a galactic canvas, revealing intricate details and previously undetectable features. What was once the stuff of speculation became visible reality. The JWST's advanced infrared sensors transcended the limits of Earthbound observation. Free from atmospheric distortion, it observed the cosmos from the cold stillness of space, offering humanity an unfiltered lens into the secrets of the universe. With each carefully calibrated movement, the telescope captured gigantic mosaics stitched from thousands of smaller images, creating mega-images that encapsulated the full essence of celestial wanderers like Oumuamua and other deep space intrigue. No international rush to understand the nature of this silent Voyager. The telescope's constant vigilance and high-resolution surveys of the heavens made it the unsung hero of one of the most important astronomical discoveries of the century. Together, JWST and Pan-STARRS 1 represent two ends of a grand continuum, one scouting the skies, the other peering deep into the soul of the universe. Their combined legacy is a testament to global scientific collaboration, where Earthbound observers and spacefaring instruments work in unison to decode the language of the cosmos. As more celestial messengers like Oumuamua arrive, carried by the tide of interstellar space, these remarkable instruments ensure that we are watching, waiting, and ready to understand. Perched atop the majestic summit of Haleakala in Maui, Hawaii, the Pan-STARRS 1 telescope rose not just as an instrument of science, but as a beacon of human brilliance, perseverance, and global collaboration. Its silhouette against the starlit sky is more than picturesque. It represents the collective ambition of humankind to understand the universe and protect our home within it. This visionary endeavor was the result of a unified effort among prestigious institutions. The University of Hawaii's Institute for Astronomy, the MIT Lincoln Laboratory, the Maui High Performance Computing Center, and Science Applications International Corporation, SAIC. Together, they gave life to the Pan-STARRS project, a mission conceived not just to observe, but to actively monitor and decode the ever-shifting tapestry of the night sky. With its 1.8-meter diameter mirror, Pan-STARRS 1, short for Panoramic Survey Telescope and Rapid Response System, was designed for wide-field imaging, capturing vast sections of the night sky in a single frame. It became a celestial sentinel, continuously scanning the heavens with unmatched vigilance. It processed terabytes of data using advanced algorithms and high-performance computing systems, allowing it to identify subtle changes, new stars, asteroids, comets, supernovae, and most notably, interstellar objects. But its mission extended far beyond astronomical curiosity. Pan-STARRS 1 was also Earth's early warning system, a guardian scanning the cosmos for near-Earth objects, NEOs, including potentially hazardous asteroids. By identifying these objects early, Pan-STARRS has played a pivotal role in planetary defense, helping scientists track and assess potential threats long before they come close. Its most groundbreaking moment came in October 2017, when it detected Oumuamua, the first known interstellar object to visit our solar system. This moment was historic, not just for what it revealed, but for what it suggested: that our solar system is not an isolated island in space, but a junction of interstellar highways briefly visited by objects from distant star systems. And as humanity stood at the threshold of this revelation, Pan-STARRS 1 became not just a telescope, it became a symbol of discovery. Its lenses captured a visitor from the stars. Its sensors chronicled a mystery that would ripple across the global scientific community. And its success reminded us all that when innovation meets collaboration, even the deepest secrets of the cosmos can come into view. In an age where space remains the final frontier, Pan-STARRS 1 teaches us that vigilance, unity, and the thirst for knowledge can bring light to the darkest corners of our universe, the gravitational norms of our solar system sparking intense debate among astronomers, astrophysicists, and theorists alike. It didn't just pass through. Oumuamua pierced the very fabric of scientific understanding, raising questions that echoed far beyond its fleeting visit. Unlike the icy comets and rocky asteroids familiar to us, Oumuamua bore no glowing coma, no tail of vaporized gas, traits typical of such visitors. Instead, its dry, tumbling, cigar-shaped body, estimated to be about 800 meters in length and only 80 meters wide, spun chaotically as it sailed through the inner solar system. This motion, irregular and unbound, suggested a non-gravitational acceleration, a puzzling propulsion not easily explained by the known forces acting upon it. Its reddish hue, revealed by spectral analysis, hinted at cosmic weathering, surface alteration due to countless years exposed to interstellar radiation. This coating, more than a color, was a chronicle, a timeline of Oumuamua's ancient voyage across the stars, possibly spanning millions of years. But it was the unexpected acceleration, a subtle yet undeniable increase in its speed as it exited the solar system, that set the scientific world abuzz. This anomaly couldn't be attributed to gravitational slingshots or known gas emissions. No visible signs of outgassing, which typically propel comets, were observed. This forced researchers to consider more exotic possibilities. Some proposed that Oumuamua could be composed of pure hydrogen ice, allowing invisible sublimation to push it forward. Others speculated about the possibility of light sail propulsion, a concept involving a thin reflective structure propelled by radiation pressure, suggesting the remote possibility of an artificial origin. Harvard astronomer Avi Loeb famously fueled the debate by suggesting that Oumuamua might be a fragment of advanced extraterrestrial technology, perhaps a derelict probe or a piece of alien engineering, an interstellar relic drifting silently through space. While this theory remains controversial and unproven, it invigorated public imagination and highlighted the importance of remaining open to the unknown in scientific inquiry. Ultimately, Oumuamua was with us only briefly. After just 11 days of high-quality observation, it faded from reach, racing away from our sun and leaving more questions than answers. Yet in that short window, it changed the way we look at the universe. It reminded us that the cosmos is not static, that visitors from distant stars are not only possible, but real. It reignited our passion for discovery and exposed the limits of our current scientific models, urging us to refine our tools, rethink our theories, and remain ever vigilant. As the journey through Oumuamua's story continues, it becomes more than a tale of a wandering rock. It becomes a cosmic message in a bottle, drifting through the void, inviting us to read between the stars. Oumuamua is not just a mere object drifting aimlessly through space. It is a celestial enigma, a cosmic wanderer whose very existence challenges our understanding of the universe. Its behavior, a complex choreography shaped by gravitational forces and other unseen influences, whispers secrets about the hidden mechanics and subtle interactions that govern the vast cosmic stage. Amid the many theories proposed to explain Oumuamua's peculiarities, one idea stands out as particularly compelling and grounded in astrophysical reasoning: the notion that Oumuamua is not an isolated wanderer born in solitude, but rather a fragment torn from a much larger celestial body. Imagine a violent cataclysmic event, perhaps the explosive collision of massive objects, or a gravitational dance gone awry, powerful enough to rip apart a star system's structure. From this colossal cosmic upheaval, shards are hurled forth, propelled across the vast interstellar void. Oumuamua, then, is one such fragment, cast into the void with tremendous velocity, journeying across millions of years and light years to arrive in our solar system. This perspective paints the interstellar space as a dynamic, ever-evolving tapestry, filled with remnants and relics of cosmic cataclysms, a celestial landscape where unexpected visitors can appear without warning. Each fragment, like Oumuamua, carries a story, a history etched into its shape, composition, and trajectory. In this grand theatre of cosmic exploration, the journey into Oumuamua's mystery transcends scientific inquiry. It is a profound invitation to expand our minds and open our hearts to the awe-inspiring wonders that lie beyond our world. As the James Webb Space Telescope prepares to unlock the cosmic secrets hidden in the depths of space and time, we find ourselves on the cusp of discovery, poised to encounter the wondrous, the unexpected, and the truly extraordinary. In this mind-bending cosmic odyssey, we are reminded that exploration is not merely about answers, but about embracing the unknown with courage and wonder. It is a voyage that unites us all in the shared human experience of seeking, learning, and marveling at the vast, beautiful universe we call home. Scientists have recently uncovered extraordinary evidence about a fascinating location within our solar system, one that holds the potential to support life beyond Earth,
the icy moon known as Enceladus, which orbits Saturn. Once thought to be a barren, frozen world, Enceladus has now emerged as a prime candidate in the search for extraterrestrial life due to its unique and complex chemical makeup. Data gathered from past missions, especially NASA's Cassini spacecraft, revealed that beneath its thick icy shell lies a hidden ocean of liquid water, enriched with organic molecules essential for life. This subsurface ocean periodically vents plumes of water vapor and ice particles through cracks near the moon's south pole, shooting material high into space. These remarkable geysers suggest that Enceladus has a dynamic interior, 1,000-mile-long UFO near Saturn. The revelations have sent shockwaves through the scientific community and the general public, raising profound questions about the nature of life beyond Earth and the mysteries hidden in the vast reaches of space. Adding to the intrigue is the testimony of former U.S. Army Command Sergeant Major Robert Dean, who has made jaw-dropping claims about alien encounters based on his extensive military experience. Dean has shared compelling accounts from his time in service, suggesting that the government possesses far more knowledge about extraterrestrial visitation than has ever been made public. His insights lend an additional layer of credibility and mystery to the discussion surrounding this colossal object near Saturn. As we explore this remarkable phenomenon, we weigh the evidence, analyze the footage, and consider the wide-ranging implications. Is this the long-awaited proof of alien life? Or are we witnessing something else entirely? A breakthrough in human interactions, involving evolving beings from diverse star systems and even cosmic realms beyond our conventional understanding. According to Dean, this non-human intelligence possesses multi-dimensional attributes with the remarkable ability to manipulate both time and matter, capabilities that challenge and expand our traditional views of the universe's fundamental nature. Switching gears to the monumental achievements of human space exploration, NASA's Voyager spacecraft serve as a testament to our scientific ingenuity and determination to uncover the mysteries of the cosmos. To power these incredible probes on their long and arduous journeys across billions of kilometers, NASA employed nuclear energy through radioisotope thermoelectric generators, RT. These RTGs function by converting the heat produced from the natural decay of plutonium-238 into continuous electrical power, ensuring that the Voyager spacecraft remain operational and transmit vital data back to Earth regardless of their immense distance from the Sun. Each Voyager probe was outfitted with approximately 722 kilograms of scientific instruments, radio systems, and power sources.